So my name is Ellie. I'm originally from England. I moved here 15 years ago. My background is as a full stack developer, and I also run a company called Exodia and ShareMint today. A bit more about myself. I have a computer science degree. I got into sort of like the blockchain development around 5 years ago. One of the earliest NFTs, maybe the first NFT to come out of Israel was us back in 2018, a collection called Crypto Fighters. And beyond that, my company has done a lot of work for the major NFT projects to come out of Israel. We've also done a lot of Web 2 development for a lot of major startups here. Today, I'm going to be speaking about Ethereum tokens. So there are two main types of tokens, ERC20 and ERC721 tokens. And the goal is that by the end of the talk, anyone watching will be able to deploy their own tokens, whether it's an NFT or a regular token, and maybe even take on freelance jobs, writing your own smart contracts. I wanted to get a bit of a feel for the room, what sort of background do people have? Like, how many people here have written a smart contract before? Okay, so we have a few people, and how many people here are sort of like full stack developers? And back-end developers. Okay, so got a rough idea, cool. We're gonna get started. What's this look like? The talk will be quite interactive. This Notion doc will be available with sort of full notes for anyone that wants to get them afterwards. Here you can sort of see a basic outline of what we're gonna cover. Sort of jumping into it. Tiny background about Ethereum. Obviously, like blockchain and crypto all started with Bitcoin. A few years later, Ethereum came along, and sort of the big revolution there was that you could write your own smart contracts. And basically, we had this idea of programmable money, where the same way as you might write code in your app to, if the temperature is greater than 75 degrees, you want to do a certain action. So with programmable money and smart contracts, the same idea might be if the price of Ethereum is above $50, then you should go and do this action. Or if 3 people in the smart contract all vote to do a certain action, then you should go do that action. Ideas like that. Or send 500 Ethereum to a contract and then split it between 2 different addresses, and you write that into the code that 250 should go to party A and 250 should go to party B. So that's sort of just a very basic background to sort of the entire idea behind Ethereum and sort of everything, sort of, I guess, the entire basis of Web3. With your smart contracts, you can write basically any code you want on the blockchain. And one of the most basic things you can do is to write your own token. So you can create tokens. Tokens are basically, there are a few different examples that we'll speak about. On Ethereum, the main token types are ERC20, ERC721, and ERC1155. And in other words, they're known as fungible tokens. These are ERC20 tokens. ERC721 tokens are NFTs, non-fungible tokens. And then the 1155 standard is sort of a mix of the two. Just sort of explaining that graphically, casino chips are examples of fungible tokens. Each red chip can be interchanged. If you give me 5 red chips and I give you 5 red chips, it's the same thing. So that's what sort of the ERC20 tokens are. That was sort of the 2017, 2018 hype of ICOs. This was the core building block for those. And to this day, many tokens are launched each day. The idea behind NFTs, the hype we've seen over the last 2 years, it's basically each token is unique. So comparing it to Pokemon, Blastoise, I can't trade one Blastoise for one Charizard because each one is different. So NFTs are sort of like these Pokemon cards, but on the blockchain. And then the last example is ERC1155, which is sort of a mix of the two above, where basically many tokens within one smart contract, where one red chip equals one red chip, but one black chip doesn't equal one black chip. Or the same with Pokemon cards. My contract might have 5 Charizards and 10 Bulbasaurs. One Bulbasaur can be traded for a Bulbasaur, but a Bulbasaur for a Charizard wouldn't be a fair trade. that's the background. We're going to talk about how these are implemented on the blockchain. And yeah, we're going to get into it. I hope I can connect to the internet here. If anyone has any opening questions right now, I'm happy to answer. Okay, so we're going to do a quick demo here. Basically, what I have open is Remix. It's basically an online editor that allows you to write Solidity code and even deploy your smart contract to the blockchain. So if you want to load this up by the way yourself, you can do so. It's at remix.ethereum.org. I'm going to go and create a new project quickly. We'll call it ICC ERC20. Hope I haven't used this name before. You can even go and they have some sort of templates that you could use over here as well. Oh, now I have to give the name again. And we already have code for our first smart contract. We'll dive into more as to what is happening here, but if you want to launch your own token on the blockchain, you could already use these 5 lines of code, or I guess 14 lines of code, to go and deploy it within Remix, and you have your own ERC20 token. And you could probably even charge a client a few $1,000s to do this for them. We're just going to edit this example a bit. Oh, sorry. Basically, a tiny bit about what's happening here. A lot of the code has been written already. So if you can see line 7, the top line, or the middle line, it says that we're importing from something called OpenZeppelin. This is basically importing the ERC20 package. And this package, basically, we can go and extend it. We can add our own logic. And all we're going to do in our case over here is we have a constructor. We're going to add a token name, a token symbol. We're going to say how many tokens we're going to have total. So let's say we could have 21 million tokens if we want it to be similar to Bitcoin. And within the constructor itself, you can see at sort of the end of the line, ERC20, it sort of goes and uses the constructor from OpenZeppelin that sort of sets up the entire contract. This is just code that other Ethereum developers have gone and written that have become the standard on Ethereum. And the one line of logic we have is we're going to mint some tokens, which is total supply. And we're going to mint it to the sender, who is basically us, who is about to deploy this smart contract. Just also to sort of say something fairly interesting, there are tokens like this that are live, things like ApeCoin with a $6 billion market cap, where they're as simple as this. The actual code looks something very, very, very similar to this, where all the contract is, it does something like this. It mints 1 billion tokens to the sender, and from there they do what they want with the tokens. But this is this is probably even production ready that you could go and deploy sort of a real token. Let's go and deploy this. So yeah, you can write sort of what code you want here, but just sort of to give an understanding of Solidity, I don't know. It looks fairly like JavaScript. You could do if there's certain logic, then you could, run a certain function and so on. We'll dive into more complex code a bit later. If you want to go and sort of compile your contract, you can do so here. I'm actually going to rename it. I'm not sure this matters, but just going to rename our contract to ICC, which is the name of our contract. Yeah, so compiling the contract, now it can be deployed basically on the blockchain. And as a next step, we're now actually going to go and deploy this for real. So we're going to have our first smart contract. We'll have the ICC token, and we'll even be able to sort of send these tokens to people. It's connected to the internet, and we're going to go and deploy this. So if you want to go deploy it yourself, basically in Remix, there's a tab on the left, which is sort of the deploy tab. You can choose your network. In our case, we're going to choose MetaMask to go and deploy it. You need to have some test Ethereum already in your wallet. So if we take a look at my wallet quickly, you can see it has 0.48 Ethereum. Go early Ethereum, it's not real. If you want to get your own Goerli Ethereum, we have what is called a faucet, and sort of this is the Alchemy one. You can basically request Ethereum from the faucet, basically, and this will allow you to do actions on the blockchain, like deploy a contract or send Ethereum to people, and so on, or call functions in a smart contract. So jumping back to Remix, we're going to go and deploy the smart contract. So to deploy, all we have to do, we need to select our contract, which we have over here, ICC. I'm going to go click deploy. Hopefully this opens MetaMask. Oh, sorry. Yeah, one thing I had to do, we need to give our token, how it's set up, it's expecting some arguments in the constructor. So I'm going to add those. We're going to call our token ICC. We'll call the symbol ICC, and we'll give like 21 million tokens. I guess we'll copy and paste from here. The reason this number looks so long is because each, by default, the ERC20 token has 18 decimals. So sort of all the zeros at the end are sort of the 18 decimals, but the number here is 21 million tokens. I'm going to transact. This opens MetaMask. For those that don't know, MetaMask is sort of an in-browser wallet. It's quite remarkable, but basically you can have a wallet within your Chrome browser. So you can have like real money sitting in your browser. Today it might be sort of, I guess, less revolutionary, but sort of just like if it's the first time you've done this, or if you think back to what you're doing here, you're opening a bank account in your browser. Anyone in the world can do it, which is just, yeah, sort of a bit insane. So I'm going to go click confirm, and this is going to go and deploy our smart contract to the blockchain. If we want, we can click on the bottom, view on Etherscan. This Etherscan is basically a block explorer. It tells us what's happening on the Ethereum blockchain. In this case, we see our transaction. It's happening on Goerli network. And yeah, our deployment should happen very soon. And you can see here, we're about to do a contract creation. The contract has now been deployed. Etherscan should update in a minute or so. Just want to sort of increase the screen size so people can see a bit better. Hopefully this is more clear, but in terms of the contract itself, there are these types of functions that you can call on ERC20. We'll dive into them a bit in a second. But basically, we have our own smart contract right now. If I want to know, for example, the name of the contract, I can see here on the left, it says ICC is the name of our contract, the symbol ICC, the total supply, also this long number that we added in. Here's the decimals I mentioned, 18. Everything in blue, by the way, is data you can read from the blockchain, and it's always free to read data. But to write data, it costs Ethereum. So the orange transactions are things like actions where you actually have to pay Ethereum to use them. So that is sort of a very brief intro to sort of deploying your own smart contract. Our own ERC20 contract is now live. Taking a step back and sort of, at a higher level, just the ERC sort of names that have been thrown out. Basically, on Ethereum, you can write any smart contract you want. You can write any code. But in order for things to, sort of platforms to be able to work together, the specific standards have been created. ERC stands for Ethereum Request for Comments. But basically, ERC20 means this is a standard token type of tokens on Ethereum. You could write your own token in a different way, but then it's just not going to interact with the rest of the ecosystem. So there are apps like Uniswap where you can do trades between different tokens, but if you don't implement the ERC20 interface, then it's not going to work with Uniswap. And the same is true for NFTs. If it doesn't implement ERC721 or ERC1155, it's not going to work with OpenSea or LuxRare or some other NFT marketplace. Diving deeper into the ERC contract itself, just so like people understand like what a token can actually do, like in terms of the code. So here you can sort of see the interface that an ERC20 token has to implement. And we actually saw it just now on the other screen as well. But how many functions do we have? We have 6 functions that basically, if you implement these and you also implement these 2 events, then you have an ERC20 token. One is the total supply. It tells you how many tokens there are in the contract. So in our case, there are 21 million ICC tokens. The next one we have here is balance of, and that tells you how many tokens each person has. So right now, Ellie, the deployer, has 21 million tokens in his account, and we could even go and check that. And if I go and do transfer, which means I send my tokens to someone else, now the balance of will be different. If I send 10 tokens to my friend, now balance of for my friend will be 10, and I'll have a bit less than 21 million tokens. There's a few other parts of the contract. Those three functions are really the core of the of the ERC20 token contract. But there are a few sort of slightly more advanced features. One is approve, which basically means I give permission for someone to use my tokens. And this is the reason this is important is because if you want to interact with other smart contracts, then the approve function becomes important. You're basically saying this smart contract can now go and use the tokens in my wallet. So if I approve Uniswap to spend 10 of my tokens, basically 10 of my ICC tokens, now Uniswap can go and do something with that. And if Uniswap, the smart contract, wants to go and actually move them from me, then they would use the transfer from function, which means they can take tokens from my wallet and move them to someone else. The reason this exists is basically that the smart contracts, if you just send tokens to a smart contract, nothing will really happen. It might get locked there. There's no way sort of for like additional actions to happen. But if you've approved your token to be used by the smart contract, now you can call methods on the smart contract, and the smart contract can start moving your tokens about. The last part here, and the allowance is just showing how many tokens I've approved. So if I've allowed Uniswap to spend 10 of my ICC tokens, this should return 10. The final part of the interfaces are basically logs. Basically, if you want to get data from the blockchain, there are all sorts of services you can use. You can run your own node. You can use services like Alchemy or Infura. And if you want to sort of know what's happening in the history, like when did Ellie send 10 tokens to someone, so you do that via events. So every time someone makes a transfer, an ERC20 token transfer, the transfer event happens, and you can use different tools basically to like find out when that happened. And if you want to do data analysis on the blockchain, you would use events like this. The transfer event is a very common event you'd be analyzing to understand what's happening for a specific token. Under the hood, we spoke a lot about so much of what we did just now was from OpenZeppelin. We wrote 3 lines of code. It didn't really explain how the code worked because OpenZeppelin went and wrote that code for us. But there's basically one main line of code that explains how the tokens work, and it's something called a mapping of balances. A mapping is like a dictionary in another language, in like Python, or like an object in JavaScript. But basically, the entire logic for the token, which is really very simple. But we have this object where we map between addresses to how many tokens you have. This is sort of an example of what this would look like in JavaScript. If you have the address 0x111 and that person has 50 tokens, here this person has 2,000 tokens, and some other address has 0 tokens because they spent all their tokens. And in our case, there's an account with 21 million tokens. So could add another token and sort of we'd have, a few more zeros. We'd have 21 million tokens in our case under our account. Where's that? Whatever number I typed in. If then account 0x222 goes and calls the transfer function that we mentioned above, and they go and transfer 5 tokens to someone else, all that happens is very simple. We sort of deduct 5 from our own balance. We move 5 to another balance. Now 0x111 address has 55 tokens instead of 50 tokens. So this data structure is basically the core part of ERC20. If you go and look at the sort of the OpenZeppelin code, sort of we even have it here if this will load up. But you would see this, there's a whole bunch of comments, but this line basically is like really the core part of how these tokens work. The entire file is probably not even It's 400 lines long, but probably 50% or more of it is comment. So it's really sort of like these multi-billion-dollar assets that people are busy trading on chain. This is how they work under the hood. What's the time? Wonderful. Okay, so yeah, we've covered everything around ERC20 tokens right now. The next part of the talk is going to be talking about ERC721 tokens, NFTs. If there are any questions at this point, I'd be more than happy to answer. Yeah, so the question was, where did time delays come in? If you, for example, you don't want to release a total supply at once. So in our case, we did just release all 21 million tokens. We gave them all to us. So in our case, we would be able to just decide, okay, in 3 months from now, I just want to send the token to someone else. Or what you might do is send it to another smart contract, and that might have some logic in it where let's say a vesting contract. That's a classic example. With regular startups, like classic vesting is you'd vest over 4 years, you'd have a 1-year cliff, and you want to do the same thing with your smart contract. So in the smart contract code, in Remix, we'd basically go and type in that people can only, there's a few different ways to write it, and you'd probably use the Open Zeppelin sort of like vesting implementation, but you'd basically go and check like, hey, the block number is block number 15 million right now. Now you can go and release to yourself another 5 million tokens. So basically all the logic you can imagine, like exactly how you'd write it in like a legal contract, that I want to release 5 million tokens every month to this user and stop after 4 years. You could do the exact same thing with a smart contract. The value of these tokens I just created is the actual transaction cost me very little. So the question was about the faucet and what the value of the tokens is. If I look at my account yesterday, I went and sort of took 0.5 Ethereum from the faucet. This is just Ethereum that is used to do transactions on the blockchain. So it doesn't say anything about the value of my token. The real value of my token right now, it's on testnet. You can sort of, I guess I could sell them for any amount I want, but the real value is 0. And yeah, so in order to sort of, here you can sort of see my transaction history. You can see I did a few mints like yesterday when I was preparing. And here we did the contract deployment. If we go and sort of take a look at it on the blockchain, it happened 10 minutes ago. And we can see the cost of this transaction was, okay, the cost was 0 basically, but the cost was this amount of ether, like 0.002 ether. And if I were to do this on like the live mainnet of Ethereum, the cost for this transaction might be a few $100s. It sort of depends on how many transactions are happening on the Ethereum network at any given moment. And it also obviously depends on the price of Ethereum if you want to convert that number into dollars. Does that answer the question? Okay, cool. So we're going to continue with the talk. The next part will be focusing on ERC721 tokens. A lot of the same concepts will come up. As we mentioned above, the ERC721 NFT token is like digital Pokemon cards. A really famous example is Bored Ape Yacht Club. If you want to, by the way, like sort of the most popular marketplace for trading NFTs is called OpenSea. So this is actually sort of a test version of OpenSea if you want to, that works with something called Rinkeby testnet if you want to go and sort of interact and play around while you're developing. It's a useful tool to know about. And Rinkeby, we use Go Early testnet, but Rinkeby also has a faucet and so on. The contract itself is slightly more complex, but like sort of not really. A lot of the same ideas exist, like balance of how many tokens does someone own, who is the owner of a specific token. So Bored Ape number 55, who is the owner of that? And you can sort of just go and ask the blockchain for that. And there's a few other sort of methods here. But the main idea is, again, like transferring tokens, approving them to smart contracts to be transferred, and so on. But overall, it's like a very, very similar concept to ERC20. The data structure behind it, like similar to before, how we explained how ERC20s work under the hood. So ERC721s, they work under the hood in a similar way. You basically have like a mapping or an object of different owners, and basically for each token ID, we say who the owner is, and that's really all an NFT is. In the blockchain, it will be represented by something like this, where token ID 0 is owned by 0x111, token ID 1, the same idea, and so on. So token ID number 4 is owned by 0x222, and your smart contract will determine sort of how many tokens are in the smart contract, what the rules are, and so on. But the sort of underneath the hood, that will be the same idea. And if we're talking about moving an NFT from one person to another, it's the same concept. If, for example, address 0x222 goes to send token 4, so basically now we see the object updated. It's no longer owned by 0x222, it's owned by 0x111. Very basic concept, basically, and that is how, that's sort of the core idea of NFTs, and how you, if you wanted to write sort of your complete own NFT from scratch without touching OpenZeppelin, but if you use OpenZeppelin, which is like sort of pre-built smart contracts for you, so that it will go, and this is basically the underlying logic for it. Another part which is relevant to NFTs is metadata. This is data which isn't stored on the blockchain. So for example, the image, if I go and like look at an NFT example, what does sort of, let's open this up. OpenSea, this is a Bored Ape collection where each NFT right now is around 77 Ethereum, or those are the cheapest ones. Here you can see these images. Now these images, basically, they're not stored on the blockchain, because each image, I'm not sure how big it is, but let's say the image is a megabyte in size. Storing a megabyte on the blockchain is extremely expensive, basically impossible. We can sort of, like every action we were doing when we were deploying our smart contract, the reason it costs money is because we're storing new data on the blockchain. If you go and mint an NFT, it's like you create a new token, create a new NFT, it costs money. And even the most basic idea of just storing, hey, token number 5 now belongs to address 0x111, that could easily cost you a few dollars. When things are like busy, it could be $50 or $100 or more. But the NFTs themselves, they have these images attached to it, and they might have like other attributes. They might allow you into an M&M event. They might allow you into a certain Discord and so on. So all of this basically happens off-chain. The images as well, which to some people is quite shocking. But like sort of all you really own on chain is like sort of the own token ID number 1. And the metadata is basically stored off-chain. And the way it works is there's a link within the smart contract that says, hey, take a look at this other URL, and that's where the image is. If we look at an example of metadata from Bored Ape Yacht Club, this is metadata for NFT number 3. And you can see basically these are the different traits it has. This is all data which is off-chain. It can be stored in a few different areas. In the case of Bored Ape Yacht Club, it's stored on something called IPFS, which is the way, like, I guess, decentralized storage. But you could store it on S3. You could store it, or you could have sort of your own API to return this data as well. If you just sort of want to understand on the blockchain itself sort of how you could even go and find this info, OpenSea went and got this data from the blockchain, but you can go and read it, like sort of every marketplace can go and read this data. You can go and read this data directly. If I go sort of take a look and I want to find what's the metadata for token number 3, I can query, give me the URI for it, and here I see it's a link to IPFS, which basically go and return, this returns the JSON. I'm going to load this IPFS URL in my browser. And here, basically, you see that the exact JSON we were talking about. You can see it links to an image. It has certain attributes. And if I go and load the image itself, also from IPFS, this is the image. And that's basically how every marketplace will go and display, or an analytics app, or anything else, really. Here you can sort of see the image. Here you can see the different traits, how they're displayed on OpenSea, and so on. And yeah, there are NFTs that have data stored on chain. If, for example, your NFT can be stored in code, for example, SVG images are code. So there are some NFTs that are sort of that you could write the that you could store the actual data on the blockchain, but for the most part, NFTs, the images and everything surrounding them are stored on IPFS or Arweave, which is sort of like decentralized storage. Or if you want, there's also nothing wrong with storing it on sort of having your own HTTP API that can return the JSON. The image might be stored on S3, really however you choose. We're now going to go and deploy actually our own smart contract, our own NFT. Maybe we'll just look through the code. Okay, let's go and quickly deploy it. But it's going to be sort of a similar idea to what we did before. Here we have a bit more code within the smart contract. So if I sort of jump to Remix, I'm going to go and create a new workspace for this. So I'm going to call it ICC ERC 721. Oh, sort of didn't want that. I'm going to go and delete the original files they added. Delete those files. I'm going to go and create a new smart contract. And I'm going to paste in my code over here. So just sort of a brief overview of what the code is doing. There's a certain price, again, very similar concepts that we're implementing what OpenZeppelin has already written for us. The code, we give a name to our token. Here we've called it Board Giraffe Conference Club. We've given a price to the NFT, basically. We have another few variables stored. Here we have our ERC721 token. The base URI, what the base URI is basically telling this token, telling other people interacting with this token where they can go and get the metadata and the images associated with it. And here we have two mint functions. One, this function, when someone calls it externally, they'll be able to go and mint an NFT for free. It just calls safe mint and creates the NFT. And if you want to require people to pay for the NFT, so here's an example where we have a bit of logic where basically the function is payable, which means that in order to call this function, you need to send Ethereum with it. And if the amount of Ethereum sent is too low, basically at the price we set was 0.08 above, if you didn't send 0.08 Ethereum with your message, basically, with your contract call, then the function is going to fail over here and it won't mint your NFT. But if you pass this line, then it will go and safely mint your NFT. This is the core of the contract. There's a few things around making sure the metadata URI can be changed and set up correctly. And the last part is being able to remove money from your smart contract. So smart contracts, they work as wallets. Basically, Ethereum has two different types of wallets. One is sort of just the regular user-owned wallets that we saw in MetaMask. You saw my wallet. And over here, if we go and deploy the smart contract, so each smart contract is also its own wallet. And if someone sends Ethereum to this smart contract address, if it doesn't have the withdraw function or way for someone else to remove money from the contract, the Ethereum will just be locked in the smart contract forever with no way to get it out. Over here, you can see that the logic that we've used, the withdraw function, all it does is it takes the entire balance of this smart contract and then it sends it to the owner, basically. And you can see also the only person that can call this method is the owner. The owner is basically the Ethereum address that is in charge and has permission to call this function. Here you can see as well the set base URI. Only the owner of the contract, which in this case is whoever deploys it, will be able to call these functions. But other functions such as mint paid and mint free, anyone can go and call basically. In the case of mint paid, this is a requirement. In the case of mint free, sort of just anyone can go and do it. And there's no restrictions. If we now go and deploy this contract, I'm just going to give it the name over here. We can go and compile the contract. If we now want, we can deploy it to the Goerli testnet. Again, we've chosen injected provider MetaMask. We want to deploy the contract Board Giraffe Conference Club. And yeah, now all we have to do is deploy. Let's see if it will allow me to do this. I'm hoping that MetaMask pops up for me. Is it? Okay. Not sure exactly why it's not running right now, but the idea is we would click deploy, and similar to before, we would go and before I went and deployed a few other contracts. So here's deploy I went and did before. You can see there is all these different sorts of methods on it. You can mint for free, you can mint for a paid amount. Functions in red are payable functions that you need to pay for. And if you're a developer yourself, once the contract has sort of been deployed to the testnet, what you want to do is go and verify it on a site like Etherscan. So I'm going to take this contract. I can copy the address from it over here. I can go and search for it in sort of Etherscan. Maybe I took the wrong contract right here. But in short, wait, let me just sort of adjust this. Where's the remix? Okay, am I using the wrong address? But in short, yeah, you can deploy your contracts. Maybe this is even an example. When you deploy your contract, it will look something like this, where it's not really sort of readable by anyone. But if you want people to sort of be able to trust it and interact with it and read it, what you can do is sort of verify the code. You send it to something like Etherscan, and then anyone can read the code. So instead of looking like this, it would look something like sort of like Bored Apes if we like find it on Etherscan. This is what like the Bored Ape contract looks like, and here you can actually see the code. You can read it. If you're looking to learn how to sort of like best practices and how to write smart contracts, this can help a lot. Looking at other NFT smart contracts, the Bored Ape Yacht Bored Ape Yacht Club is a 1.5 years old, so maybe it's sort of like not the most up to date. But yeah, if you want to know sort of the best ways to write a contract, these can definitely like sort of help educate you, and you can see sort of what other teams are doing to write your own contracts. And a lot of it, honestly, you could even copy and paste a lot of the time, and you'll have your smart contract ready. Here you can see the different things you can do on the Bored Ape contract. It's been verified on Etherscan. You can do sort of all sorts of things. Here you can see there was a reveal timestamp that they stored on chain. So here's sort of the date when it was going to be revealed. But yeah, that's basically how you go and write your own NFT smart contract. The last part is ERC1155. It's very similar concepts to before, but if you sort of, yeah, it's another form of token that we mentioned at the beginning, deploying it, creating it, very similar ideas to what we already saw. 120. Cool. Does anyone have any questions about NFTs right now, or like sort of about deploying the NFTs that we just spoke about? Great. So the last part of the talk, I think I'll just talk about like if you want to build like your own front end to sort of interact with these smart contracts. So far we've just sort of been deploying these smart contracts, but we haven't sort of really seen real interaction sort of in the real world. MetaMask is OpenSea is one place where you can go interact. We saw the tokens on Etherscan. And now you can also go and interact with them in the OpenSea sort of UI, or you could go and interact with them in other places. And when you're using OpenSea, basically what it's going to be doing, OpenSea has its own smart contracts that can interact with which can interact with different NFT tokens. And if I have 77 Ethereum and I want to go and buy this NFT, what the smart contract will allow me to do, OpenSea smart contract will be like, okay, I sent 77 Ethereum, we're going to make sure that the NFT is moved back. And the whole thing will be atomic within a single sort of Ethereum transaction. And this is sort of starting to see how different smart contracts can interact. Our smart contract with the NFT, OpenSea's, that is a very simple marketplace. Well, they've optimized it, but the core concept behind it is quite simple. We're gonna go and I guess this might be helpful to the full stack developers in the room, but we're gonna very quickly set up our own our own sort of front end and show you how you could create your own minting site. So a minting site is like a website where people can go and buy your NFT. It's basically your NFT shop. So we're going to go and quickly open up a new VS Code. So we're going to use something called Rainbow Kit. Rainbow Kit is a nice, you'll see in a second what it does for us. We're going to go in it, initialize a new project with them. We're going to give it a new name, my ICC app. This will quickly go and install a new project for us. It's going to be a Next.js app. If anyone here is familiar with Next, it's basically going to be a React app. Hopefully this installs in a second. Otherwise, I'll just use the one. Okay, let's see what happens. The app that's going to be created right now is going to look something like this. So it's going to have a pages directory. It's just going to be sort of a regular app where you can, basically like React or HTML code that you can write here. And we're going to even go and take this HTML code and go and interact with our smart contract that we deployed. Internet might be a bit slow for me. Okay, so anyway, like in short, imagine this went and completed. We won't do it completely from scratch because it's taking a bit of time. The project will go and look something like this, I guess, before we get started. Here we have sort of a blank Next.js app. If I go to localhost 3000, I'll sort of get an idea of what it looks like. Let me just save that. This is what the app looks like. When we install Rainbow Kit, basically, you get this sort of like nice interface to connect different wallets. So here it's telling me to switch network. This basically allows me to connect my MetaMask wallet that I have in the browser up here, my mini Ethereum bank account up here. It will be able to connect to this website and interact with it. We're going to go and make one change quickly, which is to allow the we're going to allow Goerli testnet for Rainbow Kit because that's the testnet we're using right now. And here you can see the app's updated. Now it's working with Goerli. It's all happy. And you can see the front end already is like, this is one line of code, by the way. It's all like to make it work. The code we're showing is this connect button from Rainbow Kit. It's like a very, very easy way to add your own connect button to your website. Yeah, they give you this entire URL. You can disconnect your address. You can switch it. You can switch network and so on. You can do all sorts of things. And the next thing we're going to do is now that we can connect our MetaMask, basically this, what it does connect, let's even, I guess, disconnect. But what connect does is it will open up and be like, hey, my website needs you to interact with, I need a wallet to interact with. And you have a few different ones that you could use. So in our case, we're using MetaMask. Rainbow is, let's say, a mobile wallet, and there's a few others. You could use Wallet Connect. You could use Coinbase Wallet. And we went and connected with MetaMask. The first time you do this, a pop-up will open in MetaMask being like, hey, do you want to reveal your address to this front end, basically, to this website? And we'll say yes. And now this website can sort of see everything about our wallet. It knows we connected. It knows how much Ethereum I have in my wallet, and so on. The next thing we're going to do is go and actually have a mint. So we are going to remove a lot of this code from the app, and we're going to add a new button called mint. This is our new front end. It has the mint button. It doesn't really do anything right now, but what we want this to do is when you click mint, MetaMask will open and be like, hey, I need you to pay some money or to sort of to confirm the transaction and mint your NFT. Just going to jump forward a bit, going to make the button a little nicer. So now it looks like this. Not important. And we want to add an on-click action. So for the on-click, what we're going to do is we're going to use a library called WAGMI. And what WAGMI does is it gives you, if you're a React developer, it provides you with React hooks, and it basically makes it very easy to interact with the smart contract. These 3 lines of code is basically what's going to enable us to go and interact. We're going to give our smart contract address. We're going to give the name of the function we want to call. In our case, it will be free mint. And we're going to give the ABI, which is basically telling our front end what functions are allowed to be called within our smart contract. So we're going to go and import the functions we need. We're going to also add the ABI we need. The ABI, just to give an idea of what it looks like, I created this file before. But it looks something like this. It's just like sort of a JSON file. Here we have an array with all sorts of different functions that can be called. First function is a constructor. Another one is, what's this function? This is approval. Well, this is an event. Let me sort of just jump down to something random. Before we mentioned transfer from. So this is a transfer from function that can be called. It gets certain inputs. You don't need to understand this file really. But this file is basically telling our code, okay, this is what the smart contract looks like. These are the different ways you can interact with a smart contract. Continuing with where we were over here, we use these two functions to go and write to the smart contract. Write just means we're going to make an update. We want to call the mint function. I think it's actually called mint free. We're going to fix that in a bit. Over here, when we click the button, the mint button, it's just going to go and call write, which goes and calls our MetaMask. Just continue on a bit more. We're going to show when the transaction is loading. We're going to show if it was successful. We're going to show some data that comes out of it. Right now, we've gone and updated the smart contract address. So this was a contract I deployed earlier today. And we're going to call it mint free as well, because that's the name of the function we gave out in our smart contract earlier. And if we save this, hopefully it goes and updates. And this is our latest front end. And if we go and click mint, hopefully this works for us. But now MetaMask is popping up. And it's asking us, this is a free mint, so we don't need to pay any Ethereum to the contract itself. But what we do need to do is, because we're making state changes on the Ethereum blockchain, we're calling a write method, we need to pay some gas, which basically allows us to make this call. So we're going to go and confirm. We're going to check we're on Goerli testnet so we don't waste real Ethereum on this. And the transaction is successful. We have the hash for it, which we can go and check on Etherscan. We're going to update our front end a little bit even so that we have this over here. We're going to add a view on Etherscan button. Just going to quickly jump through here. Here we have our button view on Etherscan. Basically, the result we got from up here, the result we got from use contract write, we get some data, and we're going to get the hash in that data, and we can go and view it on Etherscan. So let's quickly update that. And here we have a view on Etherscan button. And if we take a look, we can see sort of exactly what we wanted happened. We got a new NFT. Here you can see it's NFT number 4. If we want to learn more about it, if you want to explore, exploring Etherscan is a really good way to understand what's happening on Ethereum a lot better. But here we can see we minted an NFT from this smart contract. This was a smart contract we went and interacted with. Here you can see another few mints happened 2 hours ago when I was setting up for the talk. You can see there's one NFT holder. It could be 100 in this case, as I've only used one address. The contract itself, you can go and see the code. This is basically the code that we tried to deploy before. Here you can see the mint free function, the mint paid function. Just make it a bit bigger for people. And if you wanted, you don't have to interact with our smart contract through the front end. The exact same things you can do over here. Like if I wanted, I could do it in Etherscan. I could connect my wallet. Now my wallet is connected. This is the exact same process we just had on our own front end, just on Etherscan. And here as well, I have a write button, which allows me to run the mint-free transaction. And the exact same thing I did before, I can do on Etherscan. And I guess the idea here is that the front end you provide to users, it's sort of a convenience, but it's not necessarily critical for your app to run. You could be using Etherscan to interact with a smart contract. You could be using OpenSea. You could be using 100 different interfaces. This is sort of a more technical one, so probably most users won't want to be using Etherscan to interact with your smart contract. But if we quickly jump back, this was our mini app that we created. Like this is very close to being like something that is actually functional that you could use for a real mint. Like in this talk, I guess I'm going to take a step back, summarize what we spoke about. But yeah, over here we've gone and deployed an ERC721 token to the blockchain. We've added an XJS front end with the ability to go and mint. And yeah, this is sort of probably 80-90% of what is needed for a lot of NFT mints. Just summarizing everything we've been through. At the beginning of the talk, we spoke about sort of the different token types. We started with ERC20 tokens. Those are the tokens that are sort of like red casino chips where they can be traded one for one. Then we went and deployed on Remix, which is sort of an in-browser Ethereum editor. We then went and spoke about ERC721 NFT tokens. And finally, we've gone and sort of deployed our own smart contract for NFTs and also gone and created our own front end for it. There are a lot more complex things you can do. You can write any code you want in these smart contracts. But yeah, hopefully that gave you a good overview and intro to writing your own smart contracts. And if there are any final questions, happy to take them now. Yeah, exactly. Like how I actually got mine was from Etherscan. I think there's a few ways to get it, but if I go to, this was the 21 million one. It's just jumping back. How to get the ABI. If I click on code, I had verified the code on Etherscan. I can go and get the code basically right at the bottom of the page is this ABI that basically, it says what the smart contract can do. If you're developing yourself, by the way, there's some notes in the Notion document if anyone wants, but Hard Hat is very useful. There's a few different tools you can use for developing locally, but if you develop locally with Hard Hat, which probably do for sort of a real project, you'd be able, when you do compile, you'd be able to get the ABI from that folder as well.
Can you please share your Notion document?
Yeah, I'm gonna put the URL. Actually forgot it. There's a simpler URL, but right now we'll share it afterwards, I guess. I don't have the simple URL to hand. But yeah, there will be a link for people that want it. Any other questions? There's a few more parts in the document. The Hard Hat is mentioned there. Some use cases, what you can go and do with tokens. A few are mentioned on screen. I think we're coming towards the end of the time, so I won't really go into that. But yeah, I hope everyone enjoyed the talk and happy to answer questions one-on-one as well.